Welcome to Module 3, where we go deep on Azure Virtual Desktop and map directly to the biggest AZ-140 exam domain. Before we deploy anything, we need the architectural picture in our heads: what Microsoft manages for you, what you manage yourself, and how host pools, application groups, and workspaces fit together to actually put a desktop in front of a user. Get this model solid, and every later lesson in this module builds cleanly on top of it. Azure Virtual Desktop has a hard split. Microsoft operates the control plane, the connection broker that matches users to hosts, the web feed, the gateway that relays traffic, and diagnostics, all at global scale, and you never see a VM or a patch cycle for any of it. What you own is the session host layer, the actual Windows virtual machines running in your subscription, your virtual network, built from your image, on your patching schedule. Every troubleshooting conversation later in this course starts by figuring out which side of that line a problem lives on. New AVD engineers always ask what inbound firewall rule lets users RDP in. The answer is none. Each session host's agent opens an outbound connection to the Azure Virtual Desktop service the moment it boots and registers, and that connection stays open. When a user connects, their session rides that already open outbound channel back to the host. You never open an inbound RDP port, and you never need a public IP on the session host for this to work. You only need outbound access to the required AVD service endpoints, which we cover in the networking lesson. Every host pool is either personal or pooled, and that choice is locked in at creation. Personal host pools assign each user their own dedicated virtual machine, so state persists between sessions the way a physical laptop would. Pooled host pools share a set of interchangeable, usually non-persistent, multi-session hosts across many users, and because there's a pool to share, the broker needs a load balancing algorithm to decide where each new session lands. For pooled host pools, you pick one of two algorithms. Breadth first spreads new sessions evenly across every available host, which keeps per host load low and protects the user experience, a good default for knowledge workers. Depth first instead fills one host up to its maximum session limit before moving to the next, which minimizes the number of hosts running at once. Depth first is the natural partner for autoscale plans that are trying to consolidate load and shut down unused capacity. An application group is a logical container that publishes resources out of exactly one host pool. It can't exist on its own. A desktop application group publishes the whole desktop, and a host pool can only have one of those. A remote app application group publishes a curated set of individual applications, and a host pool can have several, each assigned to a different group of users. In every case, you grant access with a Microsoft Entra ID security group, not individual user assignments. A workspace is the layer the user experiences directly. It groups together one or more application groups into a single feed inside the remote desktop client or the web client. If you forget to associate an application group with a workspace, the user has access rights on paper but sees nothing when they sign in, a very common early support ticket. A clean design groups related remote app and desktop application groups into one workspace per business unit or use case. Any host pool, personal or pooled, can be marked as a validation environment. Validation pools receive Azure Virtual Desktop service updates and agent changes ahead of your production pools. Running a small validation pool with a handful of pilot users gives you a canary ring. If a service update or agent change introduces a regression, you catch it on a handful of test users instead of your entire production fleet. A handful of practical limits shape design at scale. The Azure Portal's host pool creation wizard caps a single operation at 500 session hosts, so large fleets are built in batches through automation. Availability sets cap at 200 virtual machines, which is one reason large pools lean on availability zones instead. Regional vCPU quota is almost always the real constraint, so request increases early. And host pool registration tokens expire on a schedule you set, so your automation needs to handle renewing them, not just the first deployment. Planning an AVD environment comes down to 4 ordered decisions. Choose the host pool type that fits the user population: personal for one-to-one persistent desktops, pooled for shared capacity. Choose the load balancing algorithm that fits your cost and performance trade-off. Design the application groups for exactly what needs to be published. And design the workspaces so each user's feed is coherent. Every remaining lesson in this module, networking, images, deployment automation, autoscale, and disaster recovery, builds directly on these 4 answers.